Test 8. Here. These were less good than they have been.
What is the overall?
Oh, the average was a C or a C plus. So, I mean, not terrible. A C average is fine. I mean, C is satisfactory, average.
Wait, how did the C make it average? Like, I mean, how is that in average?
Because everyone gets something between them.
That's just how the grading system is intended to work, where C indicates the work you did is adequate. It's not particularly good or particularly bad. It's sort of somewhere in the middle, or C being in the middle of the A, B, C, D, F scale.
That is push-ups right there.
So, yes. Good morning. Okay, so I can give you the stats on the test. Maybe you give me just a second to pull that up. So the test average was 75. So really, just a straight up C average. Again, is okay, but not great. The grade distribution looked kind of like this. That was what the grade distribution looked like, roughly. So we didn't really have any excellent scores. We had some decent ones, and then we kind of trailed off with the less good scores.
I had a good score.
The average was here. So, if you're in this group, great, keep it up. If you're in this other group, things are starting to slip. We need to fix that. The average, just for comparison, the average on the last test, test 7, was 81.4. So a slip of about 6% class average between the last test and this one. We're starting to get into some of the more troublesome things this year with the fractions, with factoring, exponents, all of that. So we don't want to have this slippage continue. Let's target these issues that we're having so that we can fix them and we don't have to worry about them the rest of the year, because all of these things now that we're working on, they're all going to keep coming up the whole year. I mean, that's been the story already. But here in particular, when we start to put some of these things together, like exponents and factoring and all of that, is when guys who were pretty confident on the stuff before, all of a sudden you start putting them together and then the confidence drops. So I want to go over a couple of the problems from this test, and then we can, then I'll open it up for a couple of minutes for additional questions, and that's going to be that. So the first one I want to go over is number 11. Now, yesterday we talked about algebra problems where the algebra isn't difficult, but the arithmetic is, because it involves fractions. 11 is a perfect example of this. In 11, we had 3 1/3 x plus 1/6 plus 5/6 x equals 1/12. Now, please get a dress code.
I can't do this.
How many times have we had this conversation?
Mr. Boss, doesn't.
How many times have we had this conversation? Is it 0, 1, or many? Okay. This problem would not cause you any issues if we didn't have fractions and mixed numbers here, but we do, so it is. With the fractions and mixed numbers, it's the same process. You just need to be a bit more careful about your arithmetic. So, just like any other equation, if we were going to solve it, what do we need to do first here? What's the first thing that we need to do? Combine like terms. Yes, and what like terms do we have that we need to combine?
3 1/3 and 5/6.
One-fifth.
Yeah, 3 1/3 x and 5/6 x. Remember, to be like terms, you have to have the same variables raised to the same powers. It doesn't matter that they don't have a common denominator right now. They're still like terms because they're both x. Over here we've got 3 1/3 x, whatever x is, and here we've got 5/6 of that. So we should be able to figure out how many x we have total. What do we get when we add 3 1/3 and 5/6? What number do we get? How do we add 3 1/3 plus 5/6? Okay, so what does it become?
3 2 6.
Plus 5/6. Okay, then what do we get? Okay, so we have 4 1/6 x plus 1/6 equals 1/12. Step number 1, we combine like terms. What's the next thing we have to do?
Divide.
Good morning. No.
Subtract 1/6.
Right, we need to get our variables on one side and our constants on the other side. We already have all the variables on the left side, so let's move all the constants to the right. The way that we'll do that is what?
Subtract.
Subtract. Subtract what?
5/6. I mean 1/6.
Yeah, subtract 1/6 from both sides. Now over here, it's going to make our lives a little easier if instead of subtracting 1/6, we subtract what?
2/12.
Yeah, 2/12. Right, 2/12 and 1/6 are the same thing. Over on the right there, notice we've got 1/12, and we're subtracting another fraction from it, so it's going to make our lives a little bit easier if we write it with that common denominator. Okay, so now what are we going to have? These cancel out. We get 4 1/6 x equals, what's 1/12 minus 2/12?
Negative 1/12.
Negative 1/12, right. 1 minus 2 is negative 1. Negative 1/12. Everybody following so far? Yes? What do we do next?
Divide
Divide by what?
4 1/6.
Divide by 4 1/6, because right now x is being multiplied by 4 1/6. We want to get that by itself. All right, so we've got x equals what? Just
25. Wait. Yeah, 25/6.
hold on. Negative 1/12 divided by 4 1/6, right? Yes. Then we're right. We're going to change this to an improper fraction. What will we get?
25.
Right. So negative 1/12 divided by 25/6. Then how do we divide fractions? Keep, change, flip.
Oh yeah.
Yeah. So negative 1/12. What? Times
6 over.
times 6 over 25. Can we simplify it all?
Mm-hmm.
What can we simplify?
2 and 1.
Yeah, we divide these by 6. 12 becomes 2, 6 becomes 1. What do we get as our answer?
Negative 1 over.
Yes, negative 1 over 50. Negative 1 over 50. The only thing that's tricky about this problem is the fractions and the mixed numbers. If you are not 100% comfortable with fractions and mixed numbers, you need to work on that. Come to me. Let's practice it. Go back earlier in the book, those earlier chapters where they practice with mixed numbers and fractions. Do the practice problems. Do the example problems. Do the problems in the lesson sets. If you hit the odd problems from the lesson sets, the answers are in the back of the textbook, so it's easy to check your work that way. And checking your own work is a habit you should get into. Other questions about 11?
No.
The next one that caused issues was number 12. Yes. All right. Number 12, they ask us to solve negative, parenthesis, x minus 3, close parenthesis, minus 4, open parenthesis, x minus 1, close parenthesis, equals 22. What do we need to do in order to solve this? Right, we need to get rid of those parentheses. The easiest way to do that is going to be to use the distributive property. So what happens to this first set of parentheses when we use the distributive property?
Negative x minus 3.
No. Yes. Remember, we need to take this is negative 1, really, and multiply each term there by it. So, negative 1 times x gives us negative x. we can think of this as plus negative 3. Negative 1 times negative 3 gives us positive 3. That's one of the mistakes that people made, where that subtraction is going to change to addition because we're multiplying it by that negative.
Minus or plus.
Yeah, is what exactly is going on with this 4? Yeah, it's a negative 4. Let's think of it as plus negative 4.
Yeah.
Okay, so then once we realize that the subtraction there means plus negative 4 times this thing, now we distribute the negative 4 and what do we get?
Negative 4x plus 4.
Right, plus negative 4x plus 4. Negative 4 times negative 1 gives us positive 4. This was where mistakes were made, was with the negative signs there. Distributing those negative signs. Going to flip the signs inside the parentheses. At this point, what do we need to do?
Like terms.
Combine like terms, what do we get on the left when we combine like terms?
Negative 5x plus 7.
Negative 5x plus 7 equals?
Yeah.
Equals what?
Equals 22.
22. Then we
Minus 7.
subtract 7,
Plus
and we get negative 5x equals 15. Divide by?
5.
No.
negative.
Divide by negative 5. What's 15 divided by negative 5?
Negative 3.
Negative 3, yes. Positive divided by a negative gives you another negative. Remember, because then we should be able to multiply it together, get back to the original. Negative 3 times negative 5 does give us positive 15. There's 12. The negative signs. That was what it was, the negative signs. Remember that subtraction, really what subtraction means is adding a negative. And if you do that, if you convert all your subtraction to adding the opposite, adding the negative, then that'll make your life easier when you do things like distribution. Because the subtraction of the 4 there, that subtraction needs to get distributed also. So if we remember that that means plus negative 4, then that negative will get distributed along with the 4. That'll help us keep track of that. Questions about 12? Oh boy, we've got 4 more to go over. Yeah, I know. I need to get those. I need to get those professorial elbow patches, like the suede.
Like, how did that happen?
They just wear out over time.
How long have you had it?
I don't know, a couple years, a few years. All right, 15 is the next one. 15 and 16 both. These two with plugging in values of variables. Yeah, 15.
15, right? Not 16.
15, they give us, well, yeah, 16 also. When we get there. 15, they give us A times B minus A to the 0 times negative 2A minus B, and they tell us that A is equal to what?
A is equal to 2 and B is equal to negative 3.
Yes, A is 2 and B is negative 3. What should we do first here?
Put in number.
No, that's something we should do first.
Oh, negative A 1.
What?
I forget what it says. Negative. I mean, minus A.
To the 0.
Yeah.
A to the 0, we can write as what?
1.
1.
Okay, A times B minus 1 times negative 2A minus B. Anytime you have something like this, see if you can make your life a little bit easier before you plug in those variables, the values of the variables. A to the 0 is just 1. All right, that's one fewer thing we need to plug in and deal with. All right, so now we can plug in the variables. Tell me every single thing that I should write here. What am I going to write first?
2 times, parentheses, negative 3, bracket, minus 1, parentheses, another parentheses, bracket, negative 2A, 2A. Oh, it's, bracket 2,
Yeah.
minus negative 3.
Put that in the bracket too.
Yeah.
When we're plugging in values for our variables, especially if those values are negative, we should put them in parentheses. Here, this value of A, we should put the brackets there because this is multiplication here. But otherwise, notice the negative 3's, I put them in brackets to help me keep track of these negative signs. All right, now to solve it, what do I need to do first?
Negative 6.
Where did you get that from?
We're multiplying 2 by negative 3.
Why did you do that?
Because
Our order of operations tells us to do what first?
Hosea is supposed to be in here,
But
he's not today.
okay.
Do you normally do an online with on the Monday, Wednesday, Tuesday, Thursday?
I do it every day. I'm
So
live
he's
right now.
already on there?
I mean, I don't know that he is, but there's two guys watching, so probably, yeah.
Okay.
All right, sure thing. Order of operations tells us to do what first? Parentheses. So what do we need to do first? Yes, -3 minus 1, and we get -4. Okay, what else do we need to do in parentheses?
-2 times 2.
Gives us minus -3.
Negative seven.
No, what's negative? What's net minus? -2 times 2 gives us -4. Minus -3. Those negatives cancel out. It becomes +3. So we've got 2 times -4 times, what do we get here? -1, which gives us +8. 2 times -4 is -8 times -1 makes it positive. The issues here were order of operations issues, especially with this guy. Minus -3. Minus a negative is the same as adding a positive.
Oh, I see what I did.
Because the negative sign switches the direction you're going in. So, right, positive, you're going that way. Minus, you go this way, but if it's a negative, we're going to flip the direction again and go like addition. We're going to go up.
There's -4 plus 3. I made it -4 minus 3.
Yeah, I saw that a lot. -4 minus 3, and then it became a 7, so you would have gotten similar kind of deal with 16, plugging in values of variables. We've got parenthesis, -3x minus y squared, close parenthesis, open parenthesis, -y minus x, close parenthesis, open parenthesis, 3x. What values do they give us for our variables? X is what?
X is -2.
And y is?
-4.
All right, now notice both of the values of these variables are negative, so we're going to have to be extra super duper specialty deluxe a la Peter T. Hooper careful. Anybody know that book?
I think so.
Yeah? Scrambled Egg Super, one of the lesser known Dr. Seuss books.
Oh.
Anyway, okay. So we're going to have to be really careful when we're plugging in the values of these variables to use parentheses. So tell me what I'm going to write, one symbol at a time.
So parentheses, -3, bracket, negative second power,
Yeah.
parentheses, minus negative, bracket, -4, bracket, minus, bracket, -2. Oh yeah.
Yeah.
Bracket, parentheses, -3, minus 2.
No.
Oh wait, yeah.
3x means what? Operation.
Times.
Yeah, 3 times x.
Yeah.
Okay. That's, I believe, what we call a buttload of negative signs and parentheses to deal with. That's okay. We're patient. We can take things one step at a time. Remember, within each set of parentheses come first in your order of operations. But within each set of parentheses, we apply the whole order of operations again. So things inside parentheses, inside other parentheses come first. Then things the exponents inside parentheses. Then the multiplication and division inside parentheses, etc. So with this first set of parentheses, what are we going to do first?
Multiply.
No.
No. Oh yeah, exponent.
Exponent, right. There's no additional things to do inside parentheses in these parentheses. However, there is an exponent. So the first thing we should do is what?
-4.
Right, we're squaring -4. What do we get?
8.
No. What's -4 times -4?
16.
Positive 16, yes.
Yeah, that's why.
Okay, then we can do, after so be careful. This is why the parentheses here are really important. You cannot cancel out this subtraction and this negative sign yet. Because canceling out negative signs is a type of what operation?
Multiplication.
Is a type of multiplication, but we're not at multiplication yet. We have to deal with the exponent first. So we deal with the exponent first and we get positive 16. All right, so minus 16, and what happens with this negative 3 times negative 2? Right, so inside the first set of parentheses, we end up with 6 minus 16. All right, what about the next set of parentheses? What do we do here?
That becomes positive 4
Positive 4
plus 2.
plus 2. Yeah, so here we just have some multiplication to deal with. Negative 4 gives us positive 4. Minus negative 2, change that to plus positive 2. And in the last parenthesis,
Negative 6.
yeah, just negative 6 from that multiplication there. All right. What's 6 minus 16?
Negative 10.
Negative 10. What's 4 plus 2?
6.
And then negative 6. What do we get when we multiply these together?
Negative 60. Minus negative 6.
I think this is easier if we do, multiplying by 10 is easy. So let's multiply the 6's together first. What's 6 times 6?
Negative 36.
Yeah, 6 times negative 6 gives us negative 36 times negative 10.
360.
Positive 360, yes. The negative 10 and the negative 6 will cancel out, and we get positive. This is the thing to really watch out for. Negative y squared means first we take whatever y is and we square it, then we do that subtraction. Exponents have to come first. It's just the way that it works. Any questions about 16? 2 more I want to go over. 18, just really quickly, a lot of mistakes on 18. A lot of guys forgot that, you see where the 7 is in the figure on 18? You see where that 7 feet is across the top of the rectangle?
Oh, yeah, I see that.
Do you see the side, like if you're at that 7 and you're going counterclockwise around the shape, where it goes straight up? That's part of the perimeter. A lot of guys forgot that, part of the perimeter. How long is that part of the perimeter there? It's 5 feet, right? We can tell because it's the same as the radius of that semicircle.
Where?
So if you're at 7, you go to the left. You see you make a right, you make a turn and you go up from there. Where it goes straight up.
Yeah.
That's part of the perimeter. If you wanted to walk around the outside of the shape, you're going to have to walk around that part too.
Oh.
And that's 5 feet. We can tell because it's the same as the radius of that semicircle.
Oh, yeah.
The last one was 19. I was a little surprised at the issues with 19. What are they asking for in 19? That was the first part of the issue, I think. What are they asking for in 19?
Volume.
The volume. What's our formula for volume in general?
I definitely got all these.
Volume. Any kind of right solid. The volume is, how do we find it? You need to know this formula.
The base times the height.
What of the base?
The base, area of the base.
Yes, area of the base times the height. So for this cylinder, all you need to do is find the area of that circular base and then multiply it by the height. That's it. The other one that I saw some issues on, not a ton, but a few guys had some issues with 20. Please, with number 20, what are they asking for in number 20? Surface area. Please don't find the area of every single side of this thing. This thing is going to have what? 1, 2, 3, 4, 5, 6, 7, 8 different sides to it for you to calculate the area separately and add them up to get the surface area. Please don't do that. Stop it. You make mistakes. You leave sides out. I think every single guy that tried to solve this problem this way left at least one side out.
Did you do?
All right.
Did you do 19?
Well, I guess I'm wrong.
No, 20.
Did you do 19?
Yeah, number 20. At 19, I'm not going to... no, 19, you just find the area of the base. It's a circle.
Okay.
And then you multiply that by the height. Right, formula for the area of a circle is? Pi r squared, right. Okay, so then you find the area, they give you the radius, then you multiply by the height of the whole thing, which they say is 10 inches. You get 250 pi cubic inches. For 20, please, 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 use the formula I give you for surface area. Why? Because it will always work, and often when you have weird shapes like this, it's actually going to be fewer steps than calculating each of these sides individually. How do we find the surface area of a right solid? What's the formula I gave you, which you should all know by now?
2 times area of the base plus perimeter of the base times height.
Yes, 2 times the area of the base plus perimeter of the base times the height. For the area of this base here, you have to split it up into 2 rectangles.
Oh,
And the area of the base you should get then is 75 square feet because the top part is 6 by 6. The bottom part is 13 by 3. You get 36 plus 39, 75. The perimeter of the base, you've got 6 different sides to add up.
wait, what?
What about what? What are you saying what about?
Oh, okay, never mind, I got it.
For the perimeter of the base, you need to add up the sides that they give you, plus don't forget that one side that they didn't label, the one that's just to the left of the 3, you see the 3 on the right, the side above that, that's part of your perimeter also. And that's going to be 7 feet. You need to add all those together, you get 44 feet for the perimeter.
So it's basically the 13 plus 9 plus 6 plus 6 plus 7 plus 3.
Yes.
Didn't I do that?
I don't know. Did you get the right answer? What'd you get for the perimeter?
I got something, but I don't know what it is.
What was the area for 20?
Can't see me.
Find it out. All right. Other problems that you wanted to ask about? You're not sure how to do.
Let me check right quick.
Okay, take just a couple minutes because I want to see if we can start 38 today.
Yeah.
Over the weekend, I don't know. We got to think about
Oh,
that.
number 3.
If Ashton keeps his jacket on for the whole class, like the rest of the class, we don't have homework. Please.
Number three, you just need to set up correctly. When we say what fraction, how do we set up these problems that have what fraction? How do we write what fraction?
Wait, number 3?
Yeah. The word fraction messes people up in these type of problems. If we say, it doesn't matter if we say what number, what fraction, what decimal, what quantity, whatever. Anytime it's a mystery value, how can we represent that? N or X, using a variable. So here, what fraction, we write that with X, and then of indicates what operation? Multiplication. X times 50 is, or how do we write that?
X times.
X, yeah, because what fraction of 50, what fraction is X of is times 50, is or equals 15. And then you solve that from there.
To be honest, I just multiplied
So it's 1 over.
I just multiplied the numerator by 2 and the denominator by 2, so I got 30 over 100, and I made it 3 over 10. I got it right.
What fraction of 50 is 15? This is how you write it.
What?
How do we write what fraction?
Shouldn't it be a fraction?
No. Because remember, your variable can represent any quantity. It could represent a fraction, it could represent a decimal. Don't get mixed up by the fact this is what fraction. Don't write a fraction. Just write a single variable.
Okay, I'm gonna write that down.
What fraction, what quantity, what value, what decimal. Just use a single variable. The problem is, if you start messing with multiple variables, once you have more than one variable, you're not going to be able to find a single solution to a problem. Which is actually a key aspect of the scientific method. All right. Oh, 38 is ratio problems. I'm not starting that today. Definitely not. All right, so if you want to ask about a couple more questions from the test, I'll open it up for that. Corrections, let's say by Tuesday.
Tuesday, why Tuesday?
Because Monday people forget things, and Tuesday we have school, and Wednesday we don't.
Really? Yay! Next week, barely any school. Why can't we just have the whole week off tonight?
Because we already at the match day that we can have all to listen to the
Can you guess it?
We have school Monday and Tuesday.
Click your
We have a long Christmas break. We end the school year very early.
Wait, when do we end? May?
June 4th. June 3rd probably is the last day that you guys have to be here. June 1st, 2nd, 3rd are your final exams.
I'm never coming back.
June 4th